Okay, so let's go ahead and do some examples. Normal distribution calculations with a calculator. Use your calculator to find the appropriate value. Show your work. Well, what does it mean by showing your work? So showing your work means draw your curve, shade, and use table A or calculator. And just because you use a calculator doesn't mean you don't write down your thought processes. So for z less than 0.58, we would go ahead and label our graph. Here's 0, here's 1. So 0.58 would be somewhere right here. And z less than that would be everything to the left. Okay. So how do we use a calculator? We are asked to find the area because we are given the z-score. So we want to use normal CDF. And that's what you would write down on your paper so that I know and other people know that you know what you're doing. And so if you remember the prompts, they end up being in parentheses, and you'll see that when you look at your calculator screen. So for this one, the lower bound line is going to be to the left. Anything to the left of this line is going to be your lower bound. So this is 0, -1. I'll label it for just to show you. -2, -3. And you want to pick a number far enough away that you're not going to have to worry about it. So I always pick -10 if it's, or you could pick -100. It's going to give you the same answer. So my lower bound is -10. My upper bound is your boundary line, so 0.58. I should have labeled that. I'm sorry. I'm going to label that right here. And you label these right here too for lower bound and upper bound. Always have to label everything. Your mean is 0. You don't just put these numbers in parentheses and think that's okay. And the standard deviation is 1. And you enter those values in as prompts, and when you get to paste, you hit enter, and you will get this answer. And for B, you do the same thing, and I'm going to go ahead and give you the answer and just make sure you know how to do it. Okay, I just want to do one of each kind of problem. For the next one, z greater than 0.26. So here's 0, here's 1, here is 0.26. So we're going to find this area. Great thing about the calculator is you don't have to worry about subtracting. Remember when we were doing anything greater than, we had to subtract that area from 1 because that'll give you the left side. So for the calculator, knows how to do that already. So you don't have to worry about it. So normal CDF, your this time your lower bound, and again, I'm bad about not labeling these. And you don't have to, as long as you show your picture and your shading. You just need to know that that's your boundary line. So 0.26 is your leftmost line, so that would be your lower bound. Your upper bound, just pick 10, 100, whatever. So lower bound, upper bound, mean. Oops, I meant to put 0 here. 1, this is your mean. This is your standard deviation. Enter those values in, and you'll get an answer of 0.3974. Well, what if you think, no, I'm not going to use a calculator? Eventually you'll want to, and there are things that you need to use it for, so it just makes sense to learn how to use it right now. You didn't have to worry about the subtraction part, so that's awesome. Now, going to E, we have z is greater than -1.19. It is less than 0.26. So 0, -1, -2, +1. So we have z is less than 0.26, but z is greater than -1.19. So you want this shaded area in between. Again, you don't have to find the, you don't have to worry about subtracting anything. So that's just why I love it. So normal CDF. And you need to put that as normal CDF just because later on you'll use other functions as well. So this time, sorry, that was -1.19, and this was 0.26. So your lower bound, your leftmost line is -1.19. Upper bound is 0.26. Mean is 0. Standard deviation is 1. And that'll give you a value of 0.4855. And let me go ahead and write down the answers to these so you can figure out what it is later. Using the calculator to find z-score. So this is where we use the other function called inverse norm. So first thing we want to do is sketch. So this is 0. And we are looking at 20% below. So remember, guys, this line right here means you have 50% to the left and 50% to the right. And you know that this section right here was 34%, and this one was whatever it was, right? 13.5%. So shading it, you don't have to be precise about it, but just shade something like this. And don't worry about that line. So you're going to use inverse norm. Your area is 0.20 because they're 20th percentile. That's your area. Your mean is 0 and your standard deviation is 1. And that will give you a z-score. Once you hit enter, it'll give you a z-score of -0.84. And if you do this one the same way, so you want 76th percentile. So think about that. This is 50th. And so 50 plus 34 is 84. So something like this would be 76%. So you want below. So this is what you're going to shade. And then do the same thing. Do inverse norm. We'll just go ahead and do this one. And you would get this, remember, from second vars on your calculator. And that'll give us an answer of 0.7063. Right. Let's do a sample problem, the same one we did before. And this is about Rafael Nadal, who averaged 115 miles per hour on his first serves. Assume that the distribution of his first serve speeds is normal, the mean of 115 miles per hour, and a standard deviation of 6 miles per hour. About what proportion of his first serves would you expect to exceed 120 miles per hour? Use the 4-step process, our favorite free response format. So one thing I guess I'll mention is if it's a normal distribution, it's often referred to as capital N, and you'll have in parentheses the mean first and then the standard deviation. You'll oftentimes see that. So we can use a calculator. So the state is written out for us. The plan is written out for us. We are going to use normal CDF because we're asked for what proportion, what percent. So normal CDF. Remember, lower bound, I guess I should be sketching it. So here's the mean of 115. This is 121, 127, 133. And we want to know exceeding 120 miles per hour. So right here, and this is the area we're interested in. So our lower bound is 120. There, I'm going to label it right up here so I have room. And then our upper bounds can be some huge number like 200 if you want. It's not going to matter. So lower bound is 120. Upper bound is going to be 200. You can even pick 1,000. Our mean is 115 because this is a normal distribution, not a standard normal. And our standard deviation is 6. And put those values in your calculator, you get 0.2033. So 20.3% of Nadal's first serves travel faster than 120 miles per hour. We're not going to do the next problem, but you would do it the same way. You would use the lower bound and upper bounds, but this would be your, I'm not going to go ahead and sketch it, but here's the calculator portion. This is one where it's between two values, and 100 would be the lower bound. The upper bound would be 110. So 100 goes here, 110 goes there. The mean was 115, and the standard deviation was 6. Again, label. And that gave us our answer. And I'm pretty much doing it most of the way, but I'm not going to worry about sketching it. So 19.6%. Okay, here's a new problem that we will do. Heights of 3-year-old females. According to the CDC Government Growth Charts website, the heights of 3-year-old females are approximately normally distributed with a mean of 94.5 centimeters and a standard deviation of 4 centimeters. What is the third quartile of this distribution? So remember, third quartile is 75th percentile. The heights of 3-year-old females have a distribution, it's normal, with a mean of 94.5 and a standard deviation of 4. The third quartile is a value with 75% of the distribution to the left. In our plan section, the graph shows the distribution with the area of interest shaded. So let's go ahead and do some labeling. So here's the mean. Oops, if I can get this stuff to work. So 94.5. And the standard deviation is 4. So that would be 98.5 right here. This would be 102.5. And this one would be 106.5. Okay, this would be 90.5. This would be 86.5. And this would be 82.5. All right, and 75th percentile, so here's 50th. This is 50th right down in the middle, and so 75 would be, again, you're just doing a rough sketch. So we want this right here. All right, so we are going to use the inverse norm because this time we are given the area, and the area is 75%. So inverse norm, yeah, went to make a V and turned out to be really bad. So 0.75 is our area. Our mean of this distribution is 94.5 centimeters, and our standard deviation is 4 centimeters. Enter all that information in your calculator, and you will get 97.2. So that is our value that we're interested. Notice this is not z-scores because it's a normal distribution. So our answer our conclusion about 75% of 3-year-old females are shorter than 97.2 centimeters.